let's talk about containers. First of all, you probably are using containers. But what is a container? And are you using them right? Well, let's get to that first question. What is a container? A container is an object or something that's holding something to transport something, which is a little vague. Let's put it in a more computer science perspective. A container is a discrete environment set up within an operating system in which one or more applications run. What? That is kind of accurate. However, if you look at the typical definition of a container, it also says something like, and I will read it for you, typically assigned only those resources necessary for the application to function correctly. So it's not just a container, it's not just something that you put in something and if it works, it runs. It only is typically assigned only the things that it needs. Hold that thought. Because people think that if we put something in a container, it is by default safe. How are we doing security? Let's put it in a container. Well, that is not always right. And I want to say to you, typically if you blindly put something in a container, the opposite is true. My name is Brian. I'm a developer advocate for Snyk, and well, we do security stuff. I'm also, as you can see, part of the community, and I do a lot of that. I do a lot of that stuff, and I really enjoy both working for the Virtual JUG and Utrecht JUG. However, we are going to talk about containers because it has exploded over the last couple of years. The adoption of containers increased remarkably. I mean, 1 billion weekly downloads, that's a huge amount, and it will grow with 40% the next year, probably. However, it's not just a tool you can blindly use. Typically not if you think in a security mindset. So I'll present to you best practices for Docker image security. Let's get started with that. First of all, your base image. Normally you build an image or you build a container with a Docker file, and you look at your Docker file, it starts with from OpenJDK, for instance, or from whatever. By default, we are used to working with that. And that means we grab a base image, typically from Docker Hub, and build our stuff on top of that. Well, what we did was we looked at the most used free base images for a research we did last year, and this was the research. This came up. We pulled the latest images from all of these 10 base images, so the latest tag, and we specifically looked at problems, at vulnerabilities, at security issues. And you see that all of these 10 images do have issues. The node image, more than 500, but still the plain Ubuntu version had over 30 problems. So they bring a lot of value, but with that value comes great responsibility and a bunch of vulnerabilities. So are you aware of them? Because most of these things are not so much in the Node application or in the Mongo application, but in the layer below that. Because that Node image or that Mongo image is also built on top of its own base image. Typically, that's a base image like Debian or Ubuntu. Looking specifically more at these images, you will see there is a lot of difference if you pick a specific image. If you pick the full Debian image, you have the full-blown experience and the full-blown amount of issues. However, if you pick Ubuntu or CentOS, it is far less. Even more if you look at Fedora or Alpine. What I want to say is, do you actually need a full-blown operating system for your application? To run that single microsystem, microservice with that 2 endpoints, do you need a full Debian distro? Think about that. If you take a smaller one, it will not only make sure that your image is smaller, which costs or which will gain you startup time, but it also saves you from a lot of issues. Typically looking at the node image, you will see that if you take a specific tag, like the Slim or the Alpine tag, you will reduce the security vulnerabilities tremendously. Well, and I can give you an overview like that Linux vulnerabilities have been up and rising the last couple of years, and that most of the times it are criticals and high vulnerabilities. So we need to keep attention of that base image. On what foundation do you build your own application? Not blindly pick one, do some research. Let's go to the next one. The least privilege principle, or least privileged user in this case. The least privilege principle is something that's very common within security. You typically do not want a user to have more privileges than needed. Just you are allowed to do whatever you need to do, typically not more. Also not less, because then your application will not work. But for a Docker file, if you do not specify a user, by default, it is insecure. Why? You're running it as a root. So if you do not specify a user, you will run it as a root, which typically is not the best thing to do. So what you can do is something like this. I created a Docker file over here based on Ubuntu, and I'm creating an application folder, and what I do is I create a new group and a new user. After copying the application files, I set myself, that new user, as the owner of that application folder. Don't forget, before actually running the command of starting up the container, that you set the user that you want to do it with. In this case, user Brian Vermeer. If you don't do that, you still run it as root. So these are the three most important lines in this application. Now you're making sure that you create a new user which is specifically bound to that application folder, and you run your application with that specific user. So no weird things will happen when somebody breaks in or somebody does something weird. And you can, for instance, turn a file deep down in the operating system. For some of the images, like the Note 10 Alpine one over here, there is already a user available for you. That user is already created for you, but you do have to set it. If you don't set the user to Node, it will fire off the command, it will not work. So set the user to the specific user you want, and if needed, create one. Find, fix, and monitor open source vulnerabilities in the operating system. We already talked a bit about the base image, but how do you actually know which base image to pick? Or over time, what happens? Well, we saw that a lot of images were built up on build packs. And these build packs are either, if you look at the Docker Hub, these build packs are either Debian based or Ubuntu based. And there are a lot of other options, but you see that typically if you pick a Debian based dat pack, and this was researched from about a year ago, and you compare that to an Ubuntu one, the Ubuntu one more or less has less issues. So how do you know that? Well, first of all, we asked a lot of people the question, when do you scan your Docker images for open source vulnerabilities? It's important to know that 50% did. However, the other half had no clue or didn't do anything. Well, let me show you something. Let me show you a bit of research. I already created and already tested 3 different images, and these are the OpenJDK 11 from Adopt OpenJDK. And you see it over here. In my terminal, I already did 3 different flavors of that. So as you can see here, this is the OpenJDK 11 latest. And this image by default brings you 22 vulnerabilities. And most of them are from Ubuntu. So the latest default one for Adopt OpenJDK is built on Ubuntu. However, I can also choose the Debian one. I tested it for you here, and as you can see, this is the Debian version, and it has 73 issues. So you have to investigate these issues if you typically want to use the Debian version. But do you need it? Ask yourself. I also checked the Alpine version, and at this point we couldn't find any issues with the Alpine version. There are some difficulties with catching Alpine version, but just making a point that by scanning you know what the problems are. So over here you can see that you can pull an image like OpenJDK, and I put the random tag behind it, and you can scan your images with Snyk container test. Of course there are other things, but I will use it like this because I can show you it. If you have your own image, you can scan it as well with a Snyk container test. And if you incorporate your file with it, we can actually give you interesting information if you can use another base image. If you switch out the base images, it would be interesting to see if it will help you decrease the amount of vulnerabilities. With Snyk container monitor and doing the same, and also adding your file, we can monitor this over time. So I just did a monitor, and it simply looks like this in your screen. What you see is that in this screen, you see that I did did a Snyk monitor over my that's wrong, over my Docker image. And what you can see is that if I'm currently using this version 1107, and it has 96 vulnerabilities. If I upgrade to an alternative one, and it gives some alternatives here, I will decrease the amount of vulnerabilities from 96 to 0. That is interesting. So, as we know, 44% of the Docker image vulnerabilities can be fixed by just simply putting in a new base image. And these images are, well, vulnerabilities will be found over time. So if an issue is there now, or is not there now, it can be added tomorrow or the week after. Point is, you should be scanning on a regular basis if your Docker image that you're using is still valid or is still free of vulnerabilities. And if there is a vulnerability, if you can switch it out with a new version or a slimmer version of your base image. So if we ask people, how do you find out about vulnerabilities in your deployed containers? 45% says that they don't, which is scary because they're already deployed and they probably will be in production for quite a long time. Mentioning that, did you know that you can already get rid of a bunch of vulnerabilities by rebuilding your containers? 20% of the Docker images vulnerabilities can be fixed by just rebuilding them. And why do you think? Why is that? Because things change over time. Look at this thing, this Docker file. I'm using Ubuntu latest, and in this point I am including an application or including a binary from Python in it. If I run it today, it will definitely be different if I run it again 3 months from now or 3 months ago. So rebuilding your application or rebuilding your Docker containers every time you build your application is a smart thing to do. Even if your application is already in production and you do not change your own binary, it is worth to just rebuild your container and deploy it again. If you rebuild your container, only take care of the caching thing in Docker. So if you build your Docker container, please add the -- no cache flag to make sure that you do not hit the cache, but are sure that you are downloading the latest version of your image or your base image. So rebuilding and using the no cache. But what can possibly go wrong? We build containers, so we think we are secure. Well, let me show you. I already spun up a container over here. And it is launching a new application, and it's localhost 3112. This is a simple application that can do photo resizing, which is an interesting thing because we're going to look into this problem, the improper input validation problem, and it's a part of ImageMagick. ImageMagick is part of the Debian distribution in this container. Looking at that one, it is a high CVSS score vulnerability and something we need to take care of. But it's a tool from the operating system that we're using and that a bunch of applications and a bunch of websites are using. And funny enough, this was already disclosed, found, and already fixed. And vulnerability is now known as ImageTragic, which is funny as it sounds like ImageMagick. However, let me show you what can go wrong. So we have the application over here, and the application is quite simple. I can choose a file, and I can choose any file. Let me just take a picture from my thing over here, and I will do, let me take this one. I open a JPEG, I open it over here, it's from Devoxx Belgium, I resize it, and the resize will be my perfect Twitter application, or my perfect Twitter picture. Cool. But now let's do something different. So, in my exploit folder, first I will go and look at the container, and I am in. So you see there's nothing here. Let's look at this file, a JPEG file. But what does this JPEG file do? We talked about improper input validation. And if you see over here, it tries to fill a URL, but it directly breaks out of that and calls this command, touch RCE1. Because this is possible, because it's not properly looked at if you can break out of the actual calling a URL or calling a JPEG, it is possible to execute this command. Just to show you, I already went into my container and you see there is no RCE1 file there. Now, let me just call that file. So, go to my taking the RCE1 file and resize it, and you see no image is there because it's actually cut out of that image and it launches the touch command. Looking back in my application or any container, and I do again you will see that the file is here. There's nothing in it, but there is a file. So it means I can execute commands. I can do arbitrary code executions. So this one is not that big of a deal, right? Let's do something more fun. So we can go in here. That is all cool. Let me get out of that. I don't need it. Need this anymore. So what am I doing now is I am going to look at the following one. I've got, you might have guessed it, an RCE2 image. And what does this image do? Well, again, we called improper input validation. And as you can see here, we again calling a URL, but with these backticks. You basically say that the part in here you have to evaluate first. And what we're doing here, we're doing a wget to a URL, and which is the local host on my machine and not the Docker image. I will show you in a second. It will call r.sh and put the input or the content of r.sh into a file r.sh, and it will call that r.sh. So what does that r.sh do? It does this. So again, it W gets something, and it calls a tar file, which is here on my local machine as well, netcat. And if you don't know what netcat does, netcat is a networking tool to interact with things on the local network. But just to make a point over here. So I'm downloading a tar file, I'm unpacking it, and I'm actually basically calling netcat. To do so, I have to do something first. I have to serve this folder as a web server. And I have to do it on port 5000. And over here. So I'm currently serving it. And what I do have to do here, I have to launch netcat to listen to port 3131. So here we're listening, we served something, and now let's upload that file. So I will choose the RCE2 file over here and resize it. And as you can see, it doesn't do anything because now it's downloading the tar file, executing it, and making a connection to my local 3131. So I'm here on my local machine with my netcat instance that listens to port 3131. So let's do something like this. And you see that I can now access the root of my container because it runs something over there. I can create a file and I can look at it and it's over here. So what I do now, I have full access of the operating system and within my terminal, within my netcat instance to connect to the container and actually execute commands. Can you imagine what can happen if I'm not using netcat but some other tar file and I'm executing it? Just because I'm using a ImageMagick version, which is part of my operating system, that is not secure. Interesting. So, what can possibly go wrong with my containers? I basically showed you. Next step, using a linter. Well, I think we all know, or a bunch of us know, things like linters or rules to help you write better code. One of the examples is SonarLint that you can use in your IDE, IntelliJ or Eclipse, or I think there's even a NetBeans version. A linter basically looks at your code and is policing you to make sure you're not making silly mistakes. So it's just enforcing a bunch of rules to prevent you from making mistakes. For Docker files, we can use HaloLint. And with HaloLint, it will warn you if you have any errors in your Docker file that can harm your system. Using things like HaloLint will prevent you for committing or actually pushing stuff and making sure that you are creating or writing good code. Of course, there can be false positives. But however, it's better to have a false positive look at it and saying, nah, it's fine, instead of finding out afterwards. So using a linter like HaloLint will give you a bunch of stuff like this, will give you pointers to see, hey, I'm using copy instead of add. Why am I doing that? Or using add instead of copy. Why am I doing that? Am I doing that for a good reason or not? So it helps you utilize and actually execute the best practices for your Docker files. It's not only about the Docker file, it's also about your application. And your application is having dependencies. And these dependencies can harm you as well. So for instance, if this is your application, and I showed this a bunch of times earlier, probably it's only this part that's your code. The others are frameworks and libraries. And we do take a lot of care about our own code with code reviews and pair programming. However, are we taking care of our own dependencies? Because my container consists of the container with the base image plus my application inside of it. So new vulnerabilities are found every single year, and it's a growing thing. If we're looking at PHP, Maven, well, PHP of course, but PHP is not that big of a deal, but Maven and NPM are rising. And we can see that most of these things are not the dependencies that you include, but the dependencies underneath. So you should be scanning these things. The last thing I want to talk about is multi-stage builds. That is something that you can do in Docker, and it's very important because the build image is not so much always the production image. We tend to do all of the same things in the build image, although we can take the two out of each other. So why not create a build image that builds your stuff, has things like Maven in it, and creates the binary, and a production image that actually is built from that build image with just the minimal amount of stuff that you need to run your application. Nothing more, nothing less. Let me give you an example. Over here, you see the naive way of building an application. I'm using a base image based on Maven 3. It's an OpenJDK 8 distribution, and I am basically running my project in there. I copy the stuff in it, and I call Maven Spring Boot run. This means that I trigger Maven to build everything, and in the end I use Maven to start the jar. But is that really necessary? On top of that, do I need that full-blown base image including Maven? Do I need Maven at all? Or do I just need Java? Do I actually need a JDK? If we have a jar that is runnable, I can simply use a Java runtime environment. So this image gives you an image that is 631 megabyte big. Of course, it's a Spring Boot image, it's already quite big, but because of the container. If I transform that container into this and I make a two-step build, first step, I use my Maven image to create the build. Then a second step, which will actually be my production image, that uses a very small Java 8 GRE, Alpine based. I only copy over the jar file and I run the jar file as a normal Java -jar. This will end up with an image that is only 132 megabytes big. So my image is smaller. I do not have all that unnecessary stuff within my image because in the end I don't need it. I only need that in the build phase. On top of that, it will save you figuring out if there are any issues with that image that goes into production. Everything that you don't put in there cannot be a problem. So with multi-stage builds, you can have the average of smaller images that contain less, so by default are more secure. More importantly, if you need to enter credentials within your build pipeline, like here, I'm using an NPM build that needs an authentication token. However, I do not want that in my production build, because if it ends up in my production build, it is there somewhere hidden in the cache or somewhere hidden in memory, and I don't want that. To do so, I can do simply a build container that contains that token, but in my production container, I only include the project itself. So I need that token to trigger NPM, same holds for Maven or Gradle if I needed a token for a private repository. But that's only in the build part. With these multi-stage builds, you can make sure that authentication tokens are not part of your image. Please be aware of that. And remember that open source is very, very cool. And attackers are targeting open source. One vulnerability can give many victims. So if you scan enough, both your container and your application, you should be safe, or at least you should be aware of what you're putting into production. So, small recap. First of all, choose the right base image. Very important, not too big. What do I need? That's basically what it is. rebuild these BIM images often, because what is the latest tag now can be different tomorrow. Scan your Docker images during development. So while you are building it, see if your image is having the right base image. Maybe you can switch it out for a better one, and make sure that over time you stay up to date. Use those multi-stage builds to come up with a small container that only has the stuff you need. Use a linter, that I showed you how to lint, and don't ever run your container as root. Containers are cool, but be responsible. Thanks for watching.
So quite a few questions already coming by. Let's start with the first one. Ernst Norlander, how do you know the number of vulnerabilities in the first few slides? Is that based on a certain scan tool? I assume that is that Snyk tool
we're using our own scanning tool, and all these vulnerabilities are basically known vulnerabilities, partially documented in the CVE, but also we do our own research. So this is based on our own research, and I can do a Snyk container and then a specific container image, and then you see these vulnerabilities, as I showed you later on with OpenJDK images and the different flavors of that. So yeah, that's how we got the numbers. And even the point is not even if the numbers are exactly correct, because over time they change. But you can see that if you're using a different image, it makes sense that you pull in more binaries. So all these binaries are a possible endpoint for, or a possible entry for well, malicious use. Let's say it like that.
Yeah, thanks. And I think that Harmjan has one of the most important questions, but I think you already answered that in chat. What keyboard are you using?
Sorry, again.
What keyboard are you using?
I'm using a DOS keyboard. A DOS keyboard, Mac keyboard. I'm pretty fond of my mechanical keyboards, and yes, during the recording you heard me typing, and I kept it in because I think it's genuine.
Very nice. The one last question by Roel Jongman. Can those images practically be exploited, though on a read-only container? Well, I think you partially showed that already, right? With the whole.
Yeah, it depends. I mean, it's always the combination of the image, how you build it, and what you put into the image. Because if your application has a vulnerability that can access the container or the operating system layer, yes, you can use it. And the point is, it's not. That's in many cases what people say, like, but they first need to get into my pipeline. Oh, but they first need to get into this or that. But if you look at, say, the 10 major hacks over the last decade, it's not just one problem. It is one problem that leads to a domino effect. Mm-hmm. And if you shape your security like an onion, so layer over layer over layer, then it will not explode into your face if something goes wrong. Because if it's only one thing, of course, if that works, if your firewall works perfectly and nobody gets in, you have a point. But only one person needs to pull the plug on something, or actually misconfigured it, or put the reset button, and then your firewall is open for a tiny little bit, and then you get into deeper and deeper. And all these things that are known can be automated. So it's not a human like me that's typing on a DOS keyboard, clicky, but it's probably a script that's doing this. So the point is layered security. It's not just one entry point. That's most of the times how major hacks happen.
Mm-hmm. Especially if you're inside the container already behind the firewall already. So
yeah, but what if and then you get into the social part. What if the person is already a part of the company? If I hire a consultant, how much do I trust that person? But he has access to my build pipeline because he needs to do work for me. And so you can go on and on and on and on. I mean, this is just one part of security. Security is so much more bigger, but yeah, it's always sliced. And I see Bram mentioning the Swiss cheese model. Every slice has some holes. Definitely, that's exactly what it is. But people still grasp the idea. But this will save me. Yeah. But what if there is a hole in that, or somebody punched a hole in it? Then you want another gatekeeper next to it to get deeper and deeper and deeper. So that's.
Yeah. Then also quite a few discussions on the usage of the latest tag. Somebody asking if using the latest tag in production is a bad idea. Somebody else asking whether why the container maintainers don't tag Alpine or Slim as the latest?
Well, that depends. That is always depends, because most of these images are general use images. And you might want to do a bunch of things in that images. You want to make it's just like a library. I want to make this available for you. And I also want to make in that default image, I want to make apt-get available for you. So that is, for some use cases, that's pretty fine, but it depends on how you use it. The point I want to make is, don't blindly use something because it's big and bold and you can do everything with it. Narrow it down to what you only need. And about the latest tag, yes, it depends on who you talk to. If you say you want to have reproducible images, you should use a tag, but then you have to manually update it. Mm-hmm. But say if you have a cron job that builds your image every week, every day, then that's not a big problem that the latest image is there, because the latest image is probably an update from the previous one, and so forth, and so go on. So, yeah, that's a discussion point, and that if you work in different ecosystems, you see that, for instance, the Node people use semantic version ranges even in their dependencies, and we as Java people want to have it strict to that point, and there you can say a bunch for both of the ways of working. Depends on how you work in your pipeline and how much do you upgrade, etc., etc. So it depends. It's a typical consultancy answer, I know, but still.
Of course, that was also what I was thinking. In my Maven, I always specify my version, so I need to update it anyway.
Yeah. But then you need to know if there is a new version. You need to scan it. You need to work it, and of course, all these things fall apart or fall together. You need to have a great test suite, and I can advocate for an hour about that. But yeah, it depends.
How often do you scan? How often do you scan for vulnerabilities and update your images?
Personally, I scan literally. It's for us. It's eating your own dog food. I'm scanning with every build, so I connect it to my Gradle build or my Maven build, or could do it on my local machine if I'm pulling a new thing in, or if I'm building a new library, and then I make sure that it's part of my CI build. And nowadays, things like GitHub Actions, it's super easy to scan these kind of things, both your machine and even your Docker image. So I try to automate as much as possible, so that I do with every build locally and every build in my pipeline will have a report on scanning it. And I don't say you have to particularly always break your build, but you should be warned by what are you putting into production, so you can make conscious decisions. That's the most important part.
And if you're looking at some applications which haven't got attention lately, the normal legacy stuff which is running for ages,
well, then you have to figure out what level of vulnerabilities are you comfortable with. And that also depends if it's inward facing, outward facing, and how much it is outward facing. You can do some prioritization on that. For instance, if you connect a Java application to our system, for different vulnerabilities, we create a score for you to see if these vulnerabilities are reachable, if there are exploits for that, if there are known exploits for that and published exploits, it will get a higher ranking. And so you see, like, okay, start with the most, well, scary one and end with the ones that are maybe not so important. But again, that is still a general heuristic and not specifically to your needs, because, well, a tool doesn't know what you're doing with it. So that is, you still need to keep your sane mind with it.
Yeah, great. Then on the build images and the usage of a user tag in that, I think there was a mention in the chat where the usage of user in your build image.
Yeah.
Would you use that both in the runtime image and the build image itself, or just in the runtime?
I would definitely use it in any case. In the last one, and I saw the comments like, you should use a user. Definitely, that's true. But I wanted to focus on a single point and not a multiple point, because that might confuse people. You should use a specific user anyway, because it still runs on an operating system. So it means that even though at this point it was safe, it might be that there is a vulnerability found in a certain Spring Boot deserialization thing, and I could enter the distribution layer or the operating system layer, and if I have root access, etc., etc. So yes, again, layered.
Just do it. Yeah. Okay, great. I think that we are through with time. Thanks for the presentation. It was awesome.
All right, thank you.
Continue speaking in the chat. It will remain open, of course. So have fun.
Yeah, thank you. Bye-bye.
Bye-bye.